Okay, so recording now. A lot of you guys were having trouble like running not the debugger and just running the ncurses programs. So if you're getting like some like unknown window type and it's not running at all, what you're gonna have to do is run your program from inside the terminal. So what you'd first make sure to do is build your program so that it's up to date. Then you're gonna go down here to this tab and click on terminal. And I'll kill the old program that's running there. Normally, you're going to start in your base directory over here, your project directory, so like in tic-tac-toe here. But your executable is located inside cmake build debug. So we'd cd into cmake build debug, and then we'll have our program there. You can see there's the summer tic-tac-toe.exe. So we would go ahead and then run that. And now our program, once it's like verified that it's good, it's now up and running, and you can interact with it. So you can see that we can like move things around and we can put pieces on. We've made some updates since class and discussion. But you know, you might have problems in your code. Things might be going wrong and you might need now to debug it. To do that, you would go to run and then attach to process and then search for your program. So I'm gonna search for summer tic-tac-toe. Click on it and it's now going to attach the debugger to that process. So we would then go make sure to set some breakpoints somewhere in our program. So I have one here at place move. And now when I go to place a move, say here, we are going to stop at this breakpoint and continue on. Notice though that unlike the prior programs where the debugger was started first and then your program was run, here we're running the program first and then attaching the debugger. This means that you can only like hit breakpoints that come after some point where your program is paused. So what you're probably going to need to do is add code near the top of your program to just scan for input. Just pause there while it waits for input so that it gives you time to attach the debugger before you move on and actually start debugging it. So since I don't actually ask for input until I get inside get valid move, I couldn't actually debug any of this code up here because it would run first before I had time to attach the debugger. So if I did want to be able to debug this code up here, I would add another command to read some input, right? Just read some character. Printf, please enter a character to continue, right? Scan it, and now the program's paused waiting for my input. Gives me time to attach the debugger, put the breakpoint in, and then carry on with my debugging. Does that make sense? You guys have any questions about that? Okay. So then we're going to pick up from where we left off yesterday. Yeah. Ncurses may or may not be installed in Codathon by default. If you do the whole copy to editor, it should be. But if you look at something like, you know, Mac install curses, right? If it's not installed already, you can run sudo on here. And there was a command that I found earlier in the class, and it's you don't maybe I want like Unix. Yeah. So what you would do is you would run this command inside the Codathon shell to install ncurses, but you do have sudo access, so it's fine. So if by default it's not working, go ahead and run the command. Anything else? Make sure you're starting that early to be able to finish in time. So yesterday we started talking about transitioning to C and C++, or from C to C++. I think like the two main topics that we talked about were references and namespaces. So what's the point of a namespace? Yeah, to prevent name collisions, right? It's so that we make sure that our names and any other names of libraries we use, if they just so happen to be the same, we're not going to get compiler errors about redefining functions, right? That's the point of using namespaces. References, when would you prefer to use a reference over a pointer? But you can do both with a pointer to the thing and a reference to it. So I would say, like, in general, one of the reasons that you might pass a reference to a function is because you do want to modify it. So absolutely. But let's say we do need to modify something inside of our function. When would we prefer a reference over a pointer? You don't have to dereference a reference. That's absolutely true. But when would we prefer the reference over the pointer, or the pointer over the reference? Yeah, if we need nullability, right? If we need to be able to check to see if the thing doesn't point to anything, then we'd have to do a pointer, right? If we just want to be able to modify something and we're guaranteed to always get something, use the reference then. Does that make sense? So let's continue. So namespaces can be nested. It's not that crazy, and it's actually pretty, pretty common. So here we have a namespace Bob, which we create just like another namespace, and we have two functions, foo and goo. And then inside the Bob namespace, we have a builder namespace. And inside there, we have foo and woo and alt foo, right? So if we're inside the Bob namespace, right, we have some code, and we call foo, what code will we run? We would run Bob's foo, right? If we were in the builder namespace, right, the Bob builder namespace, and we called foo, what would print out? Builder. If I wanted to use Bob's foo inside builder's namespace, what would I do? Bob : foo. And if I'm not inside any of the namespaces and I want to be able to access like a method inside of, say, builder, I'd have to do like Bob : builder : woo to get that to work. You can also see that in woo I call goo, but notice there is no goo defined inside the builder namespace. So what the compiler is going to do, it's going to look for a goo inside the builder namespace. It doesn't find anything. Then it's going to look for a goo inside the enclosing namespace, inside the Bob namespace, and then call Bob's goo, we call woo. I could write Bob : goo if I wanted to be very specific that I always called Bob's foo, right? But if I wanted to make that like the compiler do the resolution for me with that name, it will look in the enclosing namespace and then keep looking out and out and out until it finally finds it. Or if it doesn't find anything, it's going to give you an error and not compile, say that I can't find this thing. Make sense? There's also, we talked about the using keyword. So you can say like using namespace std. It's going to pull all the symbols in from that namespace into your current namespace. You might be very tempted, and you'll see a lot of tutorials online that do this so that they can shorten the amount of code that they need to write. So instead of having to say like std : cout or std : cl or any of the other standard functions, they would just bring that namespace in. Again, I'm going to discourage using this because it increases the chances of name collisions happening, and you want to avoid them as much as possible. One other question that was like asked the other day is like, how can I switch from like one namespace to a different namespace using the using directive? And like technically it's not possible, but the scope of a namespace lasts for the block. And a block is anything defined inside curly brackets. So like this guy right here, this is a block of code, right? And I could have like another block of code inside of this. So if I said like using like namespace, space 1, then I could say like using namespace space 2 in here. And as soon as I reach the end of this curly bracket, I would end using namespace 2 and then begin using space 1 because that's the scope that I'm in. I'm in the scope of that block. That's how you could switch from going to one to the other, but not technically doing that. And then finally, we can use the using keyword to do typedefs. Typedefs just allow you to give aliases to different types, either for more conceptual logical reasons, or because you're tired of typing out this very, very long type every single time, and you want to give it a shorter name. The syntax to do it in C++ is you say using new type name equals old type name, which is a lot clearer than doing it in C, where in C you have to say like typedef, new type name, old type name. So I might typedef an int as an age type, which I think I have this typedef backwards. No, that's the right way. I'm going to say, hey, I want to age type. It's just going to be another name for int. So everywhere I say age type, it's just another name for int. This guy over here, he's a function pointer. So you can have pointers to functions if you want. They can be kind of useful sometimes. They're used a lot in GUI programming. But this syntax is kind of hard to read. So typedef int, this function returns an integer. Its name is function pointer. That's going to be the new type that I'm going to call it, and it takes 2 ints as arguments. So fun pointer is a pointer to a function that returns an integer and accepts 2 integers as arguments. But with the using declaration, it's like using age type equals int. Age type is another name for int, or using fun pointer equals an int pointer int int. It's a pointer to a function that again takes an int, returns an int, and accepts 2 ints as arguments. I prefer the using syntax because it's just a lot clearer to me than the typedef. And again, we might use some of these later on because we will end up with some long types for when we start talking about like iterators. Any questions before we talk about containers? We probably, won't see the using keyword a ton, but it can be useful in some contexts where you have like a really long type name and you're really tired of writing that thing over and over and over again. You say using type name equals long expression, then you can use the shorter expression everywhere else. So here we're going to talk about some of the C++ standard libraries container classes. They're very similar to the Python ones, or you might say the Python ones are similar to these, and they're going to make our lives a lot easier because we don't have to deal with memory management as much if we're using these classes. So when we say string from now on, there's the string class, and then there's a C string. The C string is the array of characters that ends with a null character. The string class is the much nicer and easier thing to use. To use it, you pound include string, and if you want to create an instance of a string, it's std:\string, whatever your variable name happens to be. This reference over here, and I also recommend like the C++.com reference website. It just has like everything you want to know about C++ or some class. So constructors are ways of making instances of a string. You can see about different iterators, different methods to find on it, like what's the size? What's its length? How big can you possibly be? Please resize down to be this size. And we'll show some examples of it in a second. You can also like index it using the square bracket or the @ method, or the @member method. So over here. So if you just want to create an empty string, string my string. If you want to create a string from a C string, you say my string and then you pass in whatever you want to initialize it to. You can also create a string from some character repeated n times. You give it a character pointer and it will set it to be the first n characters. Or you can have some number and some character repeated that many times. Or you can copy a string, initialize a string as a copy of another one. So you can have std string x, it's an empty string. You can create a new string called name, it's initialized to Matthew. You can create another string called nickname and take the first 4 characters out of it. Sleep noise, it's the letter Z repeated 3 times. Or you could create a clone, right, of name. So clone has the same value as name, which would be Matthew. You can also, before I keep going, any questions on creating strings? So you can assign a string to another string, a C string or a character, and it's going to replace the contents of the string that you have with whatever you set it to. So I can say, hey, I have a string name equals Matthew. It's now equal to MATTHEW. I can set it equal to just a single letter. I can set it equal to another string. Again, another C string, or again, name equals another person. So copy one string to the other. Should look a lot like Python. Shouldn't seem too scary or too crazy. And should be like a lot nicer than using the C strings, right? Instead of having to like do stir copies all the time or reallocating and dynamically allocating the space. The string is doing that all for you on your behalf. If you want its length, you can do .length or .size. They both tell you the number of bytes in the string. If you have Unicode characters, these methods will still tell you the number of bytes in the string. So you can say, Matthew, what's its length, what's its size? They're synonyms. They both are going to give you back 7. You can index the string at some position using the square brackets, just like you could any other string. And you can also modify characters that way as well by setting them equal to some value. If you want just the first or the last character, you can do .front or .back. These are going to give you back references. And since they're references, if you set that reference equal to some character, it's going to actually modify that character inside the string as well. So you can see here I'm accessing the elements. I can also see something like, name at 1 equals I. I can access the front, access the back, could change the front, could change the back. There's also the .at method. So you can do like name.at, some in parentheses, some index. It works just like the square brackets, except if you go out of bounds, it'll throw an exception and tell you that you've gone out of bounds there. So it's probably a bit better you use .at as opposed to the square brackets, because if you go out of bounds on the square brackets, it won't tell you anything. Well, .at will report the error as your program's running. So that can help you find some undefined behavior a lot easier, because it'll tell you like, hey, I threw some exception on this line where you attempted to do this. You tried to access at index 10, but there were only 5 things. If you add 2 strings together, it will concatenate them, just like in Python. And you can also add characters to the end by doing that as well, by doing the plussing. Plus equals is also defined, so you can add stuff to the end doing it that way. You can remove characters from the end using pop back. You can put a single character onto the end by doing pushback, or you can insert a particular character at some position, or you can insert a substring at some position by doing the .insert. So here's our class name, it's ECS. I add 40 to it, so it's ECS 40. I could push back the 1, so ECS 401. If I did pop back, it would give me back the 1, and it gets removed. I can also insert at position 0 the string Matthews, and then it's Matthews ECS 40. Any questions so far about any of the member methods? Makes things a lot easier, right? .clear will take out everything inside the string, and then .erase will erase len characters beginning from start. So if we do string 1 equals something, we clear it, now gone. String 1 equals something else, and then we can erase the character, erase 5 characters beginning at position 4. So 0, 1, 2, 3, 4. Erase 5 character, or erase 0, 1, 2, 3, 4. Erase 5 characters. THING. So some else. Yeah. I don't think you can just say like .erase some position. You could probably say like, string .erase. Do you want to go from there to the end? You'd probably have to do something like get the length of the string, then subtract the position that it's at, and then you could get it to do that. And then that might be like plus or minus 1, depending on like indexing, which I'd have to think about for a moment. So the question is, do the string classes have null characters in them? No, they don't, unless you specifically add them, right? But generally with a string class, you wouldn't put any null characters in it, because it has other mechanisms for detecting how long it is. So you can check against strings. You can do less than, greater than, equals equals. They do the character by character comparison, just like you would expect. You can check to see if something's empty. Easy. You can find the first occurrence of some substring, given it a search string. You can also search from the right using rfind. So we have bear and apple, and string 3, which is zebra. Is string 1 less than string 2? Is string 2 equals string 1? Greater than? Find bra, find p, right, is empty. It all makes sense. For getting IO, like from the user input, like you want to read in a string from the user, a sequence of non-white space characters, you can again use the extraction operator. If you actually want to read an entire line, you'd say std : get line, the name of the stream, and then string. So if we were getting it from like a file, we would use the name of the file stream, which we'll get to eventually. But if we wanted to read from the input, std : cline, for std : cn. So we might say like, hey, enter your name. We can see out the entire string, read it in using the other direction, enter a line of text, prints it out to the screen, read it in using the entire line using get line, and then print it out. Some other methods, if you for some reason are using, some function that needs a C string, right? You're calling some C library that needs it. What you can do is like string.cstring, and it'll give you the C string, a const pointer to the C string. So the C string it gives you back, you can't modify, but if you just need to read from it, you're good. And then you can ask for a substring that starts at some position and is some number of characters long. So vectors are like Python's lists, right? And you can probably think of like a string is basically a Python or is a C++ vector of characters, which we'll get into what that means a little bit more. They dynamically allocate the space for themselves, and they will release that space when they're no longer needed. So super duper nice. You can push things to the back of them for doing append. You can insert things into the middle, and it'll make space for it, and then just shove it in there. And so you don't have to worry about that anymore. Probably would have made read lines a lot easier if you had something like a vector to work with. So if you want to use vector, you have to include vector, and then to specify a vector, all the elements have to be of the same type. So you do std : vector, and then in these triangular brackets, you say, well, what's the type of the vector? What are the type of the elements that should be inside of it? So you can make an empty vector, a vector that starts with space for n elements. This is like for efficiency reasons. So if you're going to have to put a lot of stuff in it, like 100 things, you could pre-allocate that space to be 100. So you have space there so that the vector doesn't have to keep resizing itself, which takes time. You can initialize it to be n things that each have some starting value. You can also make it equal to some values inside curly brackets. The first one will have value 1, the second one will have value 2, the third one will have value 3, and so on. And it'll also make enough space to fit everything. So here I can make a vector of events called v1. I can make a vector of floats called v2. There's space for 5 of them. I can make a vector of characters that's 10 big. They all start as A. And I can make a vector of strings with like Matt, Bob, and Alice as the starting elements. Any questions here? You want length, use .size. If you want to access the elements, again, you can use the square brackets just like you would with an array, or you can use .at again to access the element at position, which would look like, in case you're curious. Click, come on. You could do like v.at 3. That's the same thing as doing v square brackets 3, but again, it has that bounds checking. So if you do go out of bounds using the .at member, or the .at method, it's going to complain at you that you went out of bounds and help you find the error where it's occurring at. If you want the front, if you want the back, back. You want to add things to the end, it's .pushback. You want to remove things from the end, it's .popback. You want to make it empty, .clear. Any questions on vectors? Yeah. So I think your question is, can you have a vector of vectors? Absolutely, right? There is dynamic memory application, but it's being done on your behalf. So the vector takes care of it. You don't have to do anything with it. As soon as the vector goes away, it'll go destroy itself. And like vectors are a really good instance of where you probably want to be passing around either references if you're probably planning on modifying them inside the function, or const references if you're just reading from it. Because if you pass like whole on vectors, the class has to make a full-on copy of every single element inside of there to be passed to the function. which if you have a lot of things, can be really time consuming. So if you only needed to read from the vector, you could pass a const reference, which is like passing a pointer, super fast. And since you're just reading from it, right, and not modifying anything, you're cool. If you need to modify it, pass just a normal reference. And so you could do like a vector, a vector, a vector, a vector of strings or something if you wanted to. So like again, like if you're ever like curious, what you can do is go to this website where you can search vector. And then we're like, well, okay, where's popback? And then popback only takes no arguments, so it only returns the last thing, right? So it won't. There's no just pop. There's no just like. So like you want to remove and return something. So if you want to remove and return something, you'd probably have to do like a .at to access the member, and then do a erase to erase the person at that position. The other thing that can be useful is there's like insert, which is again like used to add elements, or like there's push back, which is used to add an element, but the element has to already be built. You can also use in place back or in place, which they started being there in 2011. And when you do in place or in place back, you specify the arguments to the constructor, which we'll get to eventually, for the object, and it will build it in place. So it's a lot faster, but it might look a little bit more complicated to use. Which I don't think, so they have a vector of integers here. They said like, I want to in place back 100, I want to in place back 200. So what it did is it actually made the space there inside the vector and then initialize it to the value, which is a lot faster than having to make the copy and then copy over all the values. Because if you're copying values via like pushback, you had to have two instances of it, right? One for the original and one for the space you now had to add in. So that's just more of an optimization kind of thing. So the question is, can you have a vector of different types? No. All the elements in the vector have to be the same type, and it's the type that you specify inside the triangular brackets when you declare its type. There are ways of sort of getting that behavior that you want via polymorphism, but the types would still all be the same. They'd all be pointers. Also, one thing with references is you cannot have arrays or vectors of references. Just FYI, you can't have that. So you couldn't say like, I want a vector of int reference. It will not compile. Any other questions? Yeah. So you wanted a two-dimensional array, right? So you'd have like a vector of ints or vector of whatever your type is, right? And your question is, how could I go through and assign them to all be equal to something? Okay, so you have like a 2D array, like a integer pointer or something. And your question is, how would I then go copy all the elements that are pointed to by this like two-dimensional array into my vector of vectors? You have to go through element by element and placing back or pushing back each time. Yeah. So how many of you guys like dictionaries? They're cool, right? I like them. They can be really useful. The corresponding thing in C++ is called a map. And again, they're going to map some key to some value. And again, just like with the Python dictionaries, you get to use your key, the index, can be of any type that you want, which is pretty cool, instead of having just to use numbers. One problem that you might be really useful is you want to look up a student by their ID to be able to find their name, or even vice versa, finding their name by their ID. Right? We could have a map of strings to the student IDs. which makes it really easy to look up. There are two types of maps. There's a map and an unordered map. The unordered map is really good about doing lookups, but iterating through the map can be kind of slow, going through all the elements at once. So if you have a lot of like insertions or deletions, or just I want to look up a particular value, the unordered map is better for that. The ordered map, which is just called map, the elements are stored in orders, so it can be more time consuming to do a lookup or an insertion, but it's much faster to do an iteration over the elements, going through all of them. Which I guess I just talked about the next slide. Does that make sense? So it's going to be problem dependent upon like which one you would prefer to use. So if you want to create an empty map, it's std : map, your key type, value type, one thing to the next. So yeah. The key types have to be immutable. I have to go look this up, but they you might not need them to be immutable, but you might need a const version of it so that it is immutable. Because like the problem is if you mutate the key, then it like what it maps to is kind of like impossible to look up because the things aren't the same anymore. So it probably has to follow those so that the restriction of being not necessarily, I guess, immutable because you declared it as const. But I should go, we'll have to go double check the documentation to see if that's actually true. And you can also try doing it to see what happens if I do a non-const thing. Will it compile? And then if you mutate it, it's probably going to break. So if you want to, or unordered map, so here we have a map, a character to a string. Again, character to a string, string to an integer. Doesn't seem too crazy. Again, to index the elements, you use the square brackets. I believe you can also use .at as well. But if you use the brackets and you do that assignment, if the key is in the map, just like in the Python's dictionary, you'll overwrite it. But if it's not there, you'll add it to it. Same thing for unordered map. So here we have like from a character to an integer. So now our map has from A to 5, from Z to 35, from an exclamation point to 32, from Z to 7. That got replaced. Replaced 35 with the 7. If you want to access an element, again, you can do .at, and it's going to return a reference so that you can modify it if you wanted to. And the difference between the at and the square brackets is if there is no key that matches it, it's going to complain at you and say, hey, that's not there. So small difference between the two. You want to check to see if the key is in the map. You can do map.count, and then you can pass in the key that you want to look for, and then it will return 1 if it's there or 0 if it's not there. So here we have a value, and if the count is equal to 1, we print that, hey, it's there. Then there's a little bit more of an example of like we put the value 10 in there, check to see if 10 is in there, it will print. Is 5 in there? It's not. So again, these type names can be really long sometime. You might have something like a map of strings to a vector of strings, and you don't want to keep saying that every time you're passing it to a function. So again, you could use a type alias for that. So you can say using my type equals this really big long thing. So I can say void some function equal of my type m. And I can also create an instance of that map by doing my type, my variable. But if we didn't have aliases, void some function accepts an std : map to an std : string to an std : vector to an std : string. M. A lot harder to read, right? And probably a lot more annoying to type. And so you can use the alias instead. If you're inside CLion and you have some type that you want to give an alias to, you can highlight the type, right click on it, and then say refactor and then put it into a typedef. And it will do all the work for you. Any questions before we keep going? Hopefully things are looking up. You're like, oh good, we get all the Python stuff back. And we're able to use it again to make solving our problems easier. So one of the things that we have to do a lot with containers, and you've probably done a lot in both this class and in your previous courses, is you have to iterate through your containers. Like for each of my things, go through it. Right? With the C style for loops, they're always like for I equals 0, I less than len. In Python, it's a lot nicer. You can say, for thing in container. C++ tries to encapsulate that same idea with an iterator. This is also going to allow you to go through things like maps, because a map doesn't have an index for you to pick out some element at. So we want to generalize the I equals start, I equals end, plus plus I. So if you want to get an iterator over a container, which will allow you to go through it, you do container.begin. It will give you an iterator to the beginning. Container.end is the end of the container, and it's not actually the last thing. It's one thing after the last thing. So if you've reached end, you don't want to dereference it anymore. To get the value of the element at the position the iterator is currently on, you dereference it with an asterisk. Some of the iterators also support addition and subtraction with ints. So if I have like an iterator to the beginning of a vector, I can do that iterator plus 5 to move 5 elements into it. Not all of them, though, support this. Iterator names are also really long, and I don't like typing them, so I use auto all the time whenever I have to use an iterator name. So if here was our vector v, its type of v.begin is a vector int : iterator. It's an iterator over a vector of integers. But it's a lot easier just to say auto iter equals v.begin. Right? I don't have to know what the type is. And so if I dereference iter, since it's at the beginning of the list of items, it's going to give me the first value. Iter plus 2, move 2 elements in, it's 8. And so a lot of times, if you have like an iterator loop, it'll be for something like for auto iterator equals v.begin. Iterator doesn't equal v.end. Plus plus iter. Go to the next thing. And this would print out all the elements inside v. So it's kind of a little bit closer to the Python syntax of saying for each element in. There are also constant iterators. Constant iterators, again, allow you to go through the elements that are inside the array, but you can't modify the element with the const iterator. You can just read the value that's there. So .cbegin, .cend for constant iterator begin, constant iterator end. Some iterators also support reverse iterations, so rbegin and rend. So like rend does not equal normal begin. So if you're using like the reverse iterators, you have to use reverse begin and reverse end to see if you've gone to the end. To use the correct types. The unordered map, it does not support reverse iteration. So I could say like for auto iterator equals iterator.cbegin, iterator doesn't equal name.cend, plus plus iterator, and I can print it out. Again, this would be it going through the reverse. I think there's also like a crbegin and a crend for constant reverse iterators as well. So when, like in general, you really want to be careful like when you're using the iterators. If you're only planning on reading from the thing, use a constant iterator. If you need to be able to modify the elements inside the thing via the iterator, then use the non-const version. This just will help provide some type safety from you from making mistakes. But if someone passes you something like a const vector, right, or a const vector reference, you can only use a const iterator to go through it. You couldn't use a non-const iterator because that would allow you to modify the vector, and then it would get angry at you because you're trying to break the constants of the elements. So when you iterate through a map, you get two things out. You get it's going to be you get an object called the pair. The pair has two members, first and second. First is the key, second is the value. So if we have a map of char to int, and A maps to 1, B maps to 12, Z maps to 9, auto iterator equals m.cbegin. We haven't reached the end. go to the next element, and then we see out iterator first, a little arrow maps a second. So A maps to 1, B maps to 12, Z maps to 9 in terms of the printing out. So the question is, will the map give you the elements in the same order that we insert them in? I'm not 100% sure, but since the map is ordered, once everything's been inserted, every time you iterate through the elements, you'd always get them in the same order. But I'm not sure if I can guarantee that they're going to be iterated over in the order that they've been inserted in. I don't think it makes that promise, but you can look at the documentation to see if it does. But you may not like iterators. What's really nice is C++ now offers a way to do the same thing using the iterative for loop that looks a lot like Python's for loop. And so you can say for element type name colon iterable. So it reads a lot like the Python for loop. For each element in the iterable, you're going to go through the elements and pick them out. This is a great place for you to use auto or const auto reference. So again, const auto reference if you just want to go through the elements and read them. Auto if you want to be able to go through them and you want a copy of the value. Auto reference if you want to be able to refer to the actual thing inside the list and be able to modify it. Right, so if you just say element type, you'll get a copy. Reference type, you'll get a reference to it to be able to modify it. You throw on const, you can't change it. So here I have my array of elements. So you can do this with the static arrays. So you can say for int x in array, print it out. Then do x plus 1. This won't change the values in the elements because we asked for an integer over here, right? We asked for a copy of the value. Or if we said for auto x, again, we get a copy and this change wouldn't affect it. Over here with this vector, for auto reference x in vect, we print the value and then do x plus equals 1. This is actually going to change the values in the vector because we asked for a reference to them. So after doing this loop, the values in the vector would be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, 11. You guys have questions about when you should use const, auto, or references with these? Yeah. You could not use auto star here because the iterative for loop is going to give you back basically something of the type of the element, not a pointer to the type of the element. Any other questions? So that's containers. Life gets better. So here we have this function, again, just add ones to each of the elements. And so I have a for auto reference, num and vec, right? I'm actually able to modify the values because one, I have a reference to the vector and I have a reference to the element, right? If I took off this reference right here, what would happen? I'd make a copy and then I would change all of the elements inside the copy, right? Or if I left off, come on, undo. Okay, I'll put it back. Or if I took off this reference right here, what would happen? I'd make a copy of these and then change the copies. If I took off both of them, I would make a copy of all the elements to be passed in, Then I would make a copy of each one of those, add one to it, and then throw away that copy. And then finally, when this function ends, throw away the copy of the vector that was passed in. So again, be careful. So if you get some kind of weird behavior, double check your references. This guy over here, oh gosh. This guy over here, I asked for a const reference to a vector. So here I can only do a vec.cBegin and cEnd. I can't ask for a normal iterator because that would be breaking the type and it would not be non-const anymore because I could modify the elements. So here I just go through and I print them out. Then here is an example of doing a dot product between the elements. So right, with a dot product, you multiply the elements in the same positions, right? And then you add them to the sum. So iterator 1 equals v1.cBegin. Iterator 2 equals v2.cBegin. Iterator 1 doesn't equal v1's end, and iterator 2 doesn't equal v2's end. Go to the next element, access the elements, multiply them together, add them to the sum. And again, I could probably do this a little bit better as being const auto reference. But let me do it. I think the problem is oh, oops. No. Non-const L value to, well, there probably was a reason I had a copy there. There probably is a way of doing this correctly without using copies of the elements. We would just have to say, oh, okay. I kind of get an idea of what's going on. We would still use auto here because we're working with iterators, not the other individual elements. And then again, hey, I got 2 minutes. We can go through the elements for each element, print it out. Doesn't seem too crazy. So next week, we will talk about smart pointers. Smart pointers make it so that you don't have memory leaks anymore in your program because they delete the stuff when the pointer dies, which is really nice. But they do have some of their own caveats and difficulties to work with. Then we'll actually get into user-defined types so that we can actually have our own classes, and we'll build on top of that from there. I will see you guys on Monday then. Yeah.
Put teammates on
Campus wire? Yeah, absolutely. If you want to. So, like, you know, with like regular arrays, right? Access the element by its position. With a map, you have a key and then access the value. It's like domain and range. Say it again. Domain and range. Like maybe, like for example, we might have like an std map of like std string. And then we just propose M. And so maybe what we want to do is we want to map people's names to their age so that we can quickly look up how old somebody is. Okay. Right? So I could do something like M at Matthew equals 28. Okay. And then, or like M.
Oh, I see what. It's basically a 2D array, but
like, so notice like our index over here is going to be the some string, right? It's not going to be a number anymore. You know, Sally, right? She is equal to 5, right? And then if I want to look up what my value is, I can do like Matthew, and this will evaluate to be 28.
just do it. Skip some time and put it after. Like every time we store a new.
So generally, so with an unordered map, the way the like where they're added into it doesn't really, it's not simplified. An ordered map, it sorts them from like I believe least to highest, right? From lowest value. Well, whatever the comparison of the type of the keys is. So yes, they would do it by ASCII value of the strings, right? I have to go look at the documentation to make sure that that's what's correct. But generally, when you're iterating through the things, you don't really care, right? You're like, I just have to go through the things, right, and do something with them. You don't tend to care which order you access them in, right?
And if we really need to, we can just write into something else.
Yeah, you can like, there's like a sorted function that you can call on it, like you like go sort it, and then you can go do the stuff, or you can copy the elements like into a vector, and then sort the vector and print it out. There are definitely ways of doing it, but if you look at the documentation for map, it might tell you how they're stored. So if you need it from lowest to highest, and that was what you wanted, then you'd be good. But I'm not 100% sure that's how the iteration works.
Wednesday's lecture going to be posted?
I was attempting to do that right now, but so yeah, it will be published today. It'll just take me a couple more minutes to get it uploaded.